Welcome to the Overview of Symantec Data Loss Prevention module of the Symantec Data Loss Prevention 15.5 Administration course. For many years, Symantec has talked with customers about their data loss prevention needs, and those customers tell us that they need to protect confidential data across a variety of vectors. To begin with, they need coverage at the network level to prevent confidential data from leaving via email, web, FTP, or instant messaging. On the storage side, customers know that confidential data sitting exposed on their repositories can be just a couple of clicks away from potentially leaving their network. Therefore, they need to cover storage as well by scanning file servers, Exchange, SharePoint, and other repositories to locate and secure confidential data. Customers also need to prevent the transfer of confidential data from endpoint computers via copy to USB, copy to network shares, printing, faxing, and so on. Meanwhile, the cloud is now a significant concern for most customers who want to prevent the loss of confidential data via cloud email and cloud storage. Finally, customers want to cover all of these potential data loss vectors with write once and deploy anywhere policies that apply to all products in their data loss prevention product line. This module will present an overview of the Data Loss Prevention Suite and how it has been designed to meet the needs of these customers. This module will be covering the following topics: an overview of the Symantec Data Loss Prevention Suite, as well as more detailed information about the Symantec Data Loss Prevention architecture. The Symantec Data Loss Prevention Suite. In this topic, we'll discuss the function and features of the products within the Symantec Data Loss Prevention Suite. In response to customer requirements, Symantec has built a data loss prevention suite over the years that now includes all of the products and components shown in this figure. DLP products cover all of the main threat vectors for confidential data: storage, endpoint, network, and cloud. Symantec DLP helps customers prevent their confidential data from leaving their network and cloud infrastructure unauthorized. On the storage side, customers need to identify confidential data exposed in file shares, databases, and other repositories, and if necessary, protect that data, for instance by quarantining it. Symantec's data loss prevention for storage offerings include Network Discover, which enables you to locate exposed confidential data on a wide variety of repositories. Network Protect lets you take action on discovered confidential files, such as quarantining these files and leaving a so-called marker file in the original location, so users will know what happened to the original file and how they may regain access if they are authorized to do so. On the endpoint, customers want to locate and protect confidential data stored on endpoint laptops and desktops. Endpoint Discover lets them do that, and the companion product, Endpoint Prevent, covers user actions on the endpoint, such as copy to USB or CD/DVD, faxing, and printing, etc. Symantec DLP's network solutions provide a layered defense. They also cover transmissions from unmanaged endpoints on which you cannot run a Symantec DLP agent, which may include contractor laptops, legacy Windows operating systems, FTP servers, and so on. Symantec DLP includes 3 network offerings. Network Monitor lets you passively monitor TCP traffic leaving your network. Network Prevent for email integrates with one or more SMTP-compliant MTAs to monitor and block outbound emails. Network Prevent for web integrates with supported web proxies to monitor and block outbound web transmissions. As organizations move more of their business into the cloud, Symantec helps them protect their data with several products. Cloud Service for email lets you monitor and block emails sent from Microsoft Office 365 and Google G Suite Gmail accounts. Cloud Prevent for Microsoft Office 365 Exchange provides another option for monitoring and preventing the transmission of confidential data from users' Office 365 email accounts. Next, Cloud Detection Service analyzes data sent by supported third-party cloud services, such as Symantec CloudSoc, a Cloud Access Security Broker or CASB application. Note that Cloud Detection Service has an especially robust integration with CloudSoc, enabling it to tell CloudSoc to block or take other actions on confidential data in motion upon upload to supported cloud applications, or to delete or take other actions on confidential data at rest residing in supported cloud applications. Finally, Cloud Storage Discover lets you scan Box Enterprise accounts for confidential data. The Enforce platform, shown at the bottom of this figure, provides centralized administration, management, policy authoring, and reporting for the Symantec DLP suite. The diagram shown here represents Symantec DLP's multi-tiered architecture, showing the components of the suite. The Enforce platform and associated Oracle database are depicted on the left. And as mentioned earlier, Enforce provides administration and reporting features for the entire product suite. In the center of the diagram, you can see the individual detection servers for the various products. These are the components that will actually analyze content, such as emails or web posts, and detect data loss incidents. Note that there is not always a direct one-to-one relationship between detection servers and products. For instance, the Network Discover, Network Protect, and Cloud Storage Discover products all run on the same detection server type, the Network Discover and Cloud Storage Discover server. The same is true of the Endpoint Prevent and Endpoint Discover products, which both run on the Endpoint server. Cloud Prevent for Office 365 Exchange, by contrast, runs on its own detection server type, as do Network Monitor, Network Prevent for Web, and Network Prevent for Email. The Cloud Service for Email and Cloud Detection Service components are detection services managed and operated by Symantec in the Symantec Cloud. On the right side of the diagram, you can see the network components that the various detection servers integrate with. The Network Discover Cloud Storage Discover server, which powers the Network Discover, Network Protect, and Cloud Storage Discover products, connects to various content repositories to scan. The Cloud Service for Email server resides in the Symantec Cloud, whilst Cloud Prevent for Microsoft Office 365 runs on a customer-operated server residing in a supported non-Symantec cloud. Both of these detection servers integrate with last-hop mail transfer agents, or MTAs, in the cloud. The Cloud Detection Service integrates with supported third-party cloud applications through a REST API. The Endpoint server, which powers both the Endpoint Prevent and Endpoint Discover products, connects to DLP agents running on endpoint computers. The Network Prevent for Email server integrates with one or more MTAs, while the Network Prevent for Web server integrates with a supported web proxy. Symantec DLP components are primarily software installations or cloud-based services. You can install most of the software components on VMware products or Hyper-V if needed. Customers use a single installer to install the Enforce platform and all detection servers, and all detection server installations are the same, meaning that exactly the same software gets installed for each detection server. The detection server type is determined when the customer registers the detection server from the Enforce administration console. In addition to the software option for on-premise detection servers, virtual appliances are available for Network Prevent for Email, Network Prevent for Web, and the REST API servers, while there is also a hardware appliance available for Network Prevent for Web. In terms of network architecture, it is also worth pointing out that the network detection servers, shown in orange at the bottom of the figure, typically reside in the DMZ. When you write a policy in the Enforce administration console, it can be deployed to any or all detection servers and used to analyze input content, whether that content is network traffic, files in shares or repositories, or files or communication on endpoint computers. When a detection server captures an incident, it sends the incident to the Enforce platform, where it is available for reporting and remediation. Typically, a Symantec DLP deployment has one Enforce platform, which is included with the purchase of any Symantec DLP product, and any number of detection servers. Oracle is required for the Enforce platform database. Customers can either bring their own Oracle license or purchase one from Symantec at a discounted price. Symantec DLP 15.5 supports two versions, Oracle 12c Enterprise Edition R2 and Oracle 12c Standard Edition R2, the difference being the number of processor cores allowed. Note that the Oracle license Symantec resells is Application-Specific Full Use, ASFU, meaning it is only for use with Symantec DLP products. Whether customers provide their own Oracle license or purchase one from Symantec, only the provided DLP database schema and Oracle 12c Enterprise Edition R2 or Oracle 12c Standard Edition R2 functionality, as specified in Symantec DLP product documentation, are officially supported for use with Symantec DLP. The Network Discover product identifies confidential data exposed or residing on file servers, databases, collaboration platforms, websites, desktops, laptops, and other data repositories. Network Protect can then automatically quarantine exposed confidential files residing on file servers or SharePoint servers to a secure location. In addition, Network Protect can encrypt confidential files discovered on file servers or SharePoint servers through integration with Symantec Information-Centric Encryption, or ICE. Both Network Discover and Network Protect are enabled by a single detection server type, the Discover server. Network Discover is required at a minimum, while a separate license key activates the additional Network Protect functionality. In this figure, the Discover server mounts a remote file system, reads the files it contains, and inspects them for violations. Using the Network Protect functionality, it then copies or quarantines confidential files found in the scan. The types of file repositories Network Discover can scan includes any file system accessible from Windows or Linux, including CIFS, SMB, NFS, Novell, and others. For file system scans, Network Discover uses the underlying operating system on the Discover server to mount and scan the remote file system. Windows file shares are the most common target for Network Discover scans. In addition to file system scans, Network Discover supports native scanning of Lotus Notes databases and any SQL database accessible via GDBC or ODBC, for instance, Oracle, Microsoft SQL Server, and IBM DB2. Network Discover can also scan Exchange and SharePoint repositories. To facilitate the scanning of certain targets, Symantec DLP offers server-based agents called scanners. These are typically installed on the target host. Scanners natively connect to the target repository to scan it and then send data back to the Discover server as XML over HTTP. Scanners send only extracted text and metadata back to the Discover server for analysis, thereby conserving bandwidth. Scanners are available for websites, such as public websites, intranets, wikis, and so on, and for specific applications such as Documentum and LiveLink. Customers can also write their own custom scanners that send data back to the Discover server via a data discovery API, thus enabling the scanning of essentially any data repository. Symantec DLP Cloud Storage Discover uses an on-premise Network Discover Cloud Storage Discover server to scan the contents of corporate cloud storage accounts. The current product version supports scanning of enterprise box cloud storage accounts, which are widely used in many organizations. Similar to Network Discover, Cloud Storage Discover requires you to configure a target which specifies which accounts to scan and how to scan them. Targets must include administrator or co-administrator credentials, with privileges for managing users and groups and downloading files. And targets may optionally include any box-specific filters for users and groups, files and folders, collaborative folders, and files or folders with shared links, along with standard filters for file types, file size, etc. Note that collaborated files are tracked and scanned only once. Cloud Storage Discover supports incremental scans. Cloud Storage Discover lets you see what confidential information is stored in your employees' accounts, the people with whom your employees share that information, and how that information is shared. For instance, whether confidential files are password protected, or if they are accessible through links that are available to unauthorized users. The product also lets you quarantine confidential files or add configurable visual tags, indicating internal use only, for instance, to confidential files. The quarantine response supports secure relocation of files to an account inbox itself or to an on-premise location. Symantec DLP Cloud Detection Service uses a cloud detector, a Symantec-hosted cloud-based detection server, to analyze data presented to it by supported third-party cloud services. It can detect incidents in the presented content and return recommended response actions to the initiating cloud services. The Cloud Detector acts as a REST endpoint that receives and responds to JSON requests from REST clients. Cloud Detection Service is currently certified to integrate with Symantec CloudSoc, a Cloud Access Security Broker, or CASB, as well as Symantec Bluecoat Web Security Services, or WSS, a cloud-based web proxy service. The integration with CloudSoc is especially robust in that Cloud Detection Service can tell CloudSoc to block or take other actions on confidential data in motion upon upload to supported cloud applications, or alternately, to delete or take other actions on confidential data at rest residing in supported cloud applications. This figure shows end users or applications transmitting, creating, or interacting with data in SaaS applications or on websites. The integrated service monitors these actions and sends details to the Cloud Detection Service Cloud Detector for analysis. Note that the specific actions that can be monitored depend on the functionality of the integrated service. For instance, WSS monitors HTTP and HTTPS transmissions from managed devices, while CloudSock monitors traffic to supported cloud applications, as well as notifications from supported native SaaS APIs. The Cloud Detector analyzes the data and contextual details such as sender name, IP address, geographic location, and device OS against your DLP policies, then captures any incidents and returns policy violations to the integrated service. The integrated service can then execute responses according to its policies. For instance, it could block users from uploading to their personal Box accounts. As mentioned earlier, in its integration with CloudSock, Cloud Detection Service can tell CloudSock which action to take as defined in your DLP policies. Note that Cloud Detection Service supports all Symantec DLP detection methods except for sensitive image recognition, that is, form matching and optical character recognition, and the Content Extraction API. Symantec DLP detection methods are covered more in the Identifying and Describing Confidential Data module of the Symantec DLP Administration course. Symantec DLP Endpoint Prevent monitors and blocks confidential data from leaving endpoint computers. It can also present an on-screen pop-up notification to inform users of policy violations. Endpoint Prevent is powered by one or more endpoint servers and by compact, stable agents that contain data loss policies and perform local detection. This figure depicts an endpoint server along with endpoint agents that are monitoring activity on endpoint computers. If a user attempts to transfer confidential data against policy, the agent executes the appropriate response, which may be to block the transfer, prompt the user to confirm the action, display an on-screen notification, or execute custom responses, such as modifying access control lists on files to remove guest access to selected files, for instance. The agent continues to provide protection even if the endpoint computer is not connected to the network, and it writes incident data encrypted to disk, regardless of whether or not there is a connection. When the agent connects to the endpoint server, it sends the incident data up to the endpoint server, which then forwards the incident data to the enforce server. Because there are differences in what Endpoint Prevent supports for Windows endpoint versus Mac endpoints, we will discuss the two types of endpoint separately. On Windows endpoints, Endpoint Prevent can monitor, but by design cannot prevent data from being downloaded to a Windows endpoint hard drive. For all other vectors discussed here, Endpoint Prevent can both monitor and block. To cover file copy and print operations, the agent intercepts file system events via Microsoft's File System Filter Driver, a standard supported API. This ensures visibility to all file system activity, including data written to internal drives or to mounted USB file systems, or data read by CD or DVD applications that are embedded in the OS. For copying and pasting, the agent intercepts clipboard operations, and for network file transfer operations, including HTTP and FTP, the agent intercepts network operations via the Windows Transport Driver interface. Email support is enabled by application plugins for Microsoft Outlook and Lotus Notes. Note that the agent does not cover generic SMTP communication. Rather, it covers only those email messages initiated from the supported clients. HTTPS support is enabled with plugins for Microsoft Internet Explorer, Microsoft Edge, and Mozilla Firefox, with application-level support for Google Chrome. The agent can also monitor and block copies to and from network shares when Windows Explorer or supported applications, browsers, and command line interfaces are used. In addition to the USB and network share coverage already described, the endpoint agent offers general access control to USB storage and network shares, including the ability to block all communications to and from such destinations. Out of the box, the agent can monitor and block file operations originating from many common applications, such as Google Chrome, Skype, and WebEx, as well as Cloud Sync applications, such as Box, Dropbox, and Google Drive. Additionally, you can configure the agent to cover other applications as needed. The agent also monitors and blocks files saved from Microsoft Word, Excel, and PowerPoint to WebDAV locations, such as Microsoft OneDrive, SharePoint, or Box. Finally, for Windows 7 and later, the agent can block the use of the print screen function. For Mac endpoints, Endpoint Prevent currently covers a subset of the functionality offered for Windows. The Mac endpoint agent monitors and blocks the copy of confidential data to network shares, excluding WebDAV locations, and to removable storage devices, including USB drives, secure digital or SD drives, and Thunderbolt storage devices. It also monitors and blocks the upload of confidential data via Google Chrome, Mozilla Firefox, and Apple Safari. Additionally, the Mac agent provides coverage for Outlook 2011 and later email, Cisco Jabber, Skype, AirDrop, and Clipboard Paste. Besides monitoring and blocking for all of these vectors, the Mac agent can also encrypt sensitive files and display on-screen notifications when policy violations are detected. The Symantec DLP roadmap for the Endpoint Prevent Mac agent aims toward feature parity with the Windows agent over time. Symantec DLP Endpoint Discover scans endpoints for stored confidential data and, for Windows endpoint computers, can quarantine such files or, via the FlexResponse API, execute custom responses on them. Endpoint Discover relies on the same endpoint servers and compact agents that are used for Endpoint Prevent, as depicted in this figure. Similar to Network Discover, Endpoint Discover requires the administrator to configure a scan target, which in this case governs the scanning of up to thousands of endpoint computers. In the target, administrators select applicable policies and can configure various scan filters, including directory filters, file size filters, and file modification date filters. Even if the endpoint computer is not connected to the corporate network or to the internet at all, the agent continues to run the scan, storing incidents in the agent's encrypted data store. When the agent connects to the endpoint server, it sends incidents up. Administrators can specify a time limit for scans, or can configure scans to end when endpoint servers no longer receive scan-related data from agents for a specified amount of time. When Endpoint Discover detects confidential files on Windows endpoint computers, it can quarantine them, or apply customized automatic responses built on our FlexResponse API. For Mac endpoint computers, Endpoint Discover will simply log an incident. Symantec DLP Network Monitor passively monitors outbound TCP traffic to detect the transfer of confidential data from an organization's network. Network Monitor does not perform blocking, but customers can use the Network Prevent products described later to block supported protocols. Network Monitor is useful for getting a quick and continuous view of data loss risk over network protocols, and it can also complement the Network Prevent products by providing additional visibility into risky network activity. For Network Monitor, the customer sets up either a switch port analyzer or SPAN, or a network tap to direct a copy of network traffic to the Network Monitor server. Alternatively, the customer can attach the Network Monitor server to a copy port on an encrypted traffic management or ETM solution, such as Symantec SSL Visibility Appliance. The server then analyzes the traffic against DLP policies to detect incidents. Customers can specify the protocols they want to monitor, such as SMTP, FTP, and HTTP. Note that Network Monitor can analyze almost any TCP-based traffic, including traffic over IP version 6. If the Network Monitor server is attached to an ETM solution such as Symantec SSL VA, it sees a copy of all network traffic, including any encrypted traffic, that is decrypted according to ETM policy. Customers can also configure the server to monitor custom protocols and to use a variety of filters per protocol to filter out low-risk traffic. In practice, when an end user sends a transmission over a configured protocol, the SPAN or TAP sends a copy of the traffic to the Network Monitor server for analysis, while the original transmission continues uninterrupted to its destination. The Network Monitor server sends any incidents up to the Enforce platform, where they are written to the Oracle database and populated in the reporting UI. Network Monitor servers are typically located in the DMZ, near the main egress points for the protocols being monitored. Symantec DLP Network Prevent for email lets customers monitor and prevent the transfer of confidential data leaving the corporate network via email. In addition to the blocking response, Network Prevent for email can trigger downstream quarantine or enforce downstream encryption of outbound emails that contain confidential data. As shown in this figure, end users send email, which goes through an email server to a mail transfer agent or MTA. The MTA initiates a transaction with the Network Prevent for email server and sends the email over for inspection. The Network Prevent server then analyzes the email while keeping the original MTA-initiated transaction open. If the email triggers any policies, Network Prevent captures the incident and sends them to the enforced platform. The Network Prevent for Email server also executes any Network Prevent for Email responses. For a blocking response, Network Prevent blocks the email and returns a 550 response, permanent delivery error, to the MTA through the original MTA-initiated transaction. For a modification response, Network Prevent adds the email headers you specify, then returns the email to the MTA over a second ESMTP transaction, and closes the original MTA-initiated transaction. The MTA then reroutes the email based on the new headers. For instance, the customer's response rule could add headers that cause the MTA to send the email to an encryption gateway. Note that this method supports just about any encryption gateway. The Network Prevent for Email server is an RFC 2821 eSMTP proxy server that integrates with any SMTP-compliant MTA, such as Symantec Messaging Gateway, Cisco Email Security, or Postfix. The Network Prevent for Email server does not store and forward messages, thus it is not an MTA. It is never the only message handler holding the message because it maintains each inbound SMTP message transaction until the outbound transaction has been closed. The messaging team has complete control over the MTA's behavior in the unlikely event that the Network Prevent for Email server becomes unavailable, whether because of routine maintenance, temporary network interruption, or some other reason. The figure shown here also depicts an architecture in which the Network Prevent for Email server operates in reflecting mode, meaning that it returns inspected emails to the same MTA in which it receives them. It is also possible to run it in forwarding mode, in which the Network Prevent for Email server forwards inspected emails to a downstream MTA, different from the upstream MTA from which it received the emails. Network Prevent for Email supports MX forwarding and the inspection of TLS encrypted traffic, meaning it can be used to inspect outbound email traffic forwarded to a software as a service or SaaS provider. For details on MTA requirements for compatibility, on reflecting and forwarding mode, on methods for routing email to and from the Network Prevent for Email server, or any other information about the Network Prevent for Email product, see the Symantec Data Loss Prevention MTA Integration Guide for Network Prevent for Email. Symantec DLP Network Prevent for Web lets customers monitor and prevent the transfer of confidential data via web transmissions. The Network Prevent for Web server integrates with an HTTP, HTTPS, or FTP proxy server using the ICAP or SICAP protocol for inline active web transaction management. If it detects confidential data in web content, it can remove the sensitive content or block the transaction entirely. Network Prevent for Web supports integration with Bluecoat Proxy SG, Symantec Web Gateway, McAfee Web Gateway, Cisco Web Security, F5, WebSense Web Security, and Squid proxies. For details on the latest proxy support, including the specific protocols supported for each proxy, please see the Symantec Data Loss Prevention System Requirements and Compatibility Guide. This figure represents an end user sending a web transmission, for instance a web request, out to the internet via a corporate web proxy. Using the ICAP or SICAP protocol, the proxy forwards the request to the Network Prevent for Web server for inspection. If a transmission triggers a Symantec DLP policy, the Network Prevent for Web server captures an incident and forwards it to the enforced platform for reporting. The Network Prevent for Web server sends the proxy an ICAP response that reflects the response rule in the triggered policy. If your policies contain no Network Prevent for Web responses, the ICAP response tells the proxy to let the transaction go through. Otherwise, the ICAP response tells the proxy to block the request or remove the sensitive content and return only the sanitized request to the proxy. Network Prevent for Web can process an organization's outgoing as well as incoming transactions. For outgoing HTTP or HTTPS requests, such as web emails and blog posts, Network Prevent for Web can monitor, block, or perform content removal on these requests. It can also monitor or block FTP requests. For incoming HTTP or HTTPS transactions, for instance when an employee tries to access an internal web server from a cafe, Network Prevent for Web can act in monitor or blocking mode. The customer's data loss prevention requirements determine whether Network Prevent for Web is used for inspecting outgoing and incoming transactions. Cloud Service for Email inspects software as a service or SaaS email coming from Microsoft Office 365 Exchange Online and Google G Suite Gmail. It can also inspect email from on-premise Microsoft Exchange servers at customer sites for organizations that have not yet migrated or are not currently planning to migrate to cloud email services. If Cloud Service for Email detects content that violates DLP policies, it can block, modify, or redirect email as specified in your policy. Cloud Service for Email relies on a Symantec Cloud Detector to perform detection. It also relies on other services to act as the outbound mail transfer agent, or MTA, for routing safe email messages to their final destinations. Customers who have purchased the Symantec Email Security.Cloud service can use it to route email for final delivery. Both Cloud Service for Email and Email Security.Cloud are hosted in the Symantec Cloud. Alternatively, Cloud Service for Email supports using Office 365 reflecting mode to route inspected Microsoft Office 365 email back to Exchange Online for final delivery. This requires the customer to set up outbound and inbound connectors in the Office 365 Admin Center to forward mail from Office 365 to Cloud Service for Email, and then reflect the processed mail back to Office 365 for final routing to recipients. For more details on this operation, see the Symantec Data Loss Prevention Cloud Service for Email Implementation Guide. To use Cloud Service for Email, the customer applies the appropriate license to enforce, submits the Symantec Email Security.Cloud provisioning form to Symantec, uploads an enrollment bundle when registering the Cloud Detector with Enforce, and then configures Microsoft Exchange Server, Office 365 Exchange Online, or Google G Suite Gmail to forward mail to the Cloud Detector. The enrollment bundle configures the connection between the on-premise Enforce server and the Cloud Detector, and also initiates certificate creation with Symantec MPKI, which is used to generate and manage certificates for Cloud Service for Email. Cloud Service for Email is available at an annual per-user maintenance-inclusive subscription rate, which customers can purchase for multiple years in advance. Cloud Service for Email is not included in any bundles, for instance the DLP suite. It must be purchased separately. In summary, Symantec offers two data loss prevention products for storage. Network Discover scans content repositories for confidential files, and Network Protect takes protective action on discovered files, quarantining them, for instance. For protection on the endpoint, Symantec DLP offers the following: Endpoint Prevent, for monitoring and blocking confidential data from leaving endpoint computers, and Endpoint Discover, which scans endpoint computers to locate and optionally quarantine confidential files. Symantec DLP offers network protection for your organization with these products. Network Monitor passively monitors a copy of outbound network traffic. Network Prevent for Email can monitor and prevent confidential data from leaving over SMTP. Network Prevent for Web can monitor and prevent confidential data from leaving over HTTP, HTTPS, and FTP. The following products can provide data loss prevention for your cloud environments. Cloud Storage Discover scans cloud storage accounts for confidential files and provides optional quarantine functionality. Cloud Detection Service analyzes data sent by supported third-party cloud services, such as Symantec CloudSock. And Cloud Service for Email protects cloud-based email. Symantec Data Loss Prevention Architecture. In this topic, we'll discuss system requirements and typical architecture of the Symantec Data Loss Prevention suite. This topic will build on the product descriptions of the previous topic by going into more detail on the inner workings of Symantec DLP. First, we'll briefly describe how detection servers analyze content, and then we'll discuss sample performance statistics, sample system requirements, virtualization options, hybrid, meaning combining cloud and on-premise architecture examples, and architectural redundancy and high availability options for the Symantec DLP product suite. Before proceeding, it may be useful to review the Symantec DLP architectural diagram, which shows the Enforce server, the Oracle database, the various detection server types, along with the network components with which the detection servers integrate. Symantec DLP detection servers perform a detection process that consists of different stages and components, where information is processed and analyzed to prevent data loss and to perform incident remediation. As shown in this figure, when a detection server receives input content, such as an email, ICAP request, crawled files, and so on, the application layer component, layer 7, splits the message into several parts: header, subject, body, and attachments. If the message contains an attachment, the content extraction component is invoked to identify the file type and extract text and subfiles. Extracted content is normalized and passed to the detection component for policy evaluation. If there is a match, an incident is created and persisted to disk, and a separate process sends incidents to the enforce server. If there is no match, no incident is created and the message is not analyzed further. When planning your Symantec DLP architecture, it is helpful to have some sample performance statistics for the various components. Note that the following statistics are general examples only, and that actual performance in production will vary based on hardware, network topology, traffic and file filters, your DLP policies, and other factors. Nevertheless, the following sample performance statistics can be helpful during the planning stage of your implementation. For Network Discover and Cloud Storage Discover servers, each detection server can scan up to 31 gigabytes per hour, and for Cloud Storage Discover, up to 23 gigabytes per hour. For Cloud Service for Email and Cloud Prevent for Microsoft Office 365 Exchange servers, performance will vary with the customer's service level agreement for email delivery, customized vendor cloud architecture, and so on. For more information, please see the product documentation. For endpoint servers, Endpoint Prevent and Endpoint Discover can accommodate up to 30,000 agents. For Endpoint Discover, each endpoint agent can scan approximately 5 gigabytes per hour. These endpoint server sample statistics assume no exact data matching fingerprint detection, which is described later in this course. Each Network Prevent for Email server can analyze 30 to 50 emails per second, and each Network Prevent for Web server can analyze up to 230 megabits per second. Each Network Monitor server can analyze up to 330 megabits per second on Windows, or 600 megabits per second on Linux natively, using standard NICs. To analyze traffic of up to 900 megabits per second, a Network Monitor server requires a Napatech network measurement card on Windows, or a Napatech or Endace card on Linux. Keep these sample statistics in mind as you consider the hybrid architecture and architectural redundancy in HA scenarios described later in this topic. This table shows the sample minimum system requirements for the enforce server and the various detection servers. These requirements are tailored to large organizations defined as having more than 10,000 employees, or having more than 40 megabits of network traffic, and requiring robust policies for detection. Note that these are minimum requirements and that your organization may require more CPU cores than indicated here. There are a few important items that are worth highlighting. First, the Enforce platform and all detection servers can run on 64-bit Windows Server 2008 R2 Service Pack 1, Windows Server 2012 R2, Windows Server 2016, Red Hat Enterprise Linux, and Oracle Linux. Note that the Enforce platform and the detection servers do not have to run on the same operating system. For instance, a customer can run Enforce on Windows and run a detection server on Linux, or vice versa. Note also that the Network Prevent for Email, Network Prevent for Web, and REST API detection servers are available as virtual appliances, while Network Prevent for Web is also available as a hardware appliance. The Enforce server should have 16 gigabytes of RAM, and detection server hosts should have between 8 and 16 gigabytes of RAM, and possibly more depending in part on the number and size of DLP policies the customer expects to run. Finally, it is important to be familiar with the Network Interface Card or NIC requirements for Enforce to detection server communication, and to understand that Network Monitor requires 2 NICs, one for communication with Enforce, and the other to receive a copy of traffic from the span port or network tap. This figure shows the sample requirements for the Symantec DLP Endpoint Agent, required for the Endpoint Prevent and Endpoint Discover products. Note that the agent runs on Windows 7 SP1, Windows 8.1, Windows 10 version 15.1.1 and later, Windows Server 2008 R2, Windows Server 2012 R2, and Mac OS X 10.11 through 10.14, including systems running System Integrity Protection. For complete details on system requirements for product components and associated third-party products, please see the Symantec Data Loss Prevention System Requirements and Compatibility Guide. Symantec supports running Symantec DLP servers on VMware, ESXi 6.x, and Windows Hyper-V virtualization products, with some exceptions that are noted below, provided that the virtualization environment is running a supported operating system. At a minimum, customers must ensure that each virtual server environment matches the system requirements for servers described in the Symantec Data Loss Prevention System Requirements and Compatibility Guide. It is important to note the following support details when planning a virtual server environment. Symantec supports running the Oracle database server in Windows Hyper-V, but not VMware ESXi. If you install the Enforce server in ESXi, you must install the Oracle database on physical hardware. Symantec does not support single server installations, that is, running Oracle, Enforce, and a detection server on a single host in any virtualization environment. Finally, endpoint servers are supported in virtualization environments only for configurations that do not exceed the recommended number of connected agents. A variety of factors will influence virtual machine performance, including the number of CPUs, the amount of dedicated RAM, and the resource reservations for CPU cycles and RAM. The virtualization overhead and guest operating system overhead can lead to a performance degradation in throughput for large datasets compared to a system that runs on physical hardware. Customers should test virtualized components of Symantec DLP and use their own test results as a basis for sizing deployments to virtual machines. For additional information on running network detection servers on virtual machines, please see the Symantec Data Loss Prevention Network Monitor and Prevent Performance Sizing Guidelines available in the Symantec DLP knowledge base. Symantec DLP offers appliances for some detection server types. Virtual appliances are available for the REST API detection server, the equivalent of the Cloud Detection Server Detector, which receives content for detection analysis through a REST API, as well as for Network Prevent for Web and Network Prevent for Email detection servers. These virtual appliances are supported on VMware ESXi 5.5.0 Update 2 and ESXi 6.5. There is also a hardware appliance available for the Network Prevent for Web detection server. These appliances are all optional for a Symantec DLP implementation because Network Prevent servers can be installed on an organization's own hardware or virtual machine, while the REST API detection server can be deployed as a Symantec-managed cloud detection service Cloud Detector. For organizations that determine a virtual or hardware appliance is appropriate for their situation, Symantec recommends that each appliance service no more than 10,000 users. As more customers move their infrastructure to the cloud, Symantec DLP is providing more options for protecting cloud storage and cloud email, and for running more DLP components in the cloud for convenience and lower TCO. Many Symantec DLP implementations have on-premise as well as cloud components. Some components are designed specifically for the cloud, such as Cloud Service for Email and Cloud Storage Discover. Other components that have typically run on-premise in the past are now also supported to run in Amazon Web Services, such as Network Prevent for Email servers, Endpoint servers, and Network Discover and Cloud Storage Discover servers. This section presents a couple of sample hybrid architecture scenarios to illustrate some of these options. The figure shown here depicts a hybrid cloud and on-premise architecture in which Symantec DLP Cloud Service for Email protects Office 365 Exchange email, while an on-premise endpoint server, powering both Endpoint Prevent and Endpoint Discover, and the accompanying endpoint agents protect endpoints both on and off the network. Meanwhile, a Network Discover server implemented on-premise scans local data repositories, while an on-premise Cloud Storage Discover scans Box for Business accounts in the cloud. Many organizations now use cloud-based email and storage, which means architectures such as this represent a growing segment of Symantec DLP customers. This diagram shows a second example of hybrid architecture. In this case, an organization makes use of Amazon Web Services in the cloud for some of its infrastructure. For instance, the organization runs several CIFS and SharePoint content repositories in the AWS cloud. For this reason, the organization has located some of its Symantec DLP components into the cloud as well, such as a Network Discover server and a Cloud Storage Discover server to scan cloud-hosted repositories efficiently, and an endpoint server to handle agents running off-network. Additionally, the organization has implemented Cloud Detection Service and integrated it with Symantec CloudSock to monitor traffic bound for supported cloud applications, such as Microsoft OneDrive. All Symantec DLP detection servers and cloud detectors report to a single on-premise Enforce server. Note that although the organization is not implementing Cloud Storage Discover functionality in this example, we show it in this figure because when you install the Network Discover server software, you are also installing the Cloud Storage Discover server software, and vice versa. Symantec DLP has many fault tolerance features built in. For instance, when an endpoint agent is not connected to the endpoint server, it still continues to detect violations and notify and block according to your policies, while storing the incidents in a local encrypted data store. When the agent is able to reconnect, it pushes incidents up to the endpoint server, which forwards them to Enforce and into the Oracle database. Similarly, if for any reason there is a temporary loss of communication between a detection server, for instance an endpoint server or a network monitor server, and Enforce, the detection server retains the incidents until the connection is restored, and then pushes the incidents up to Enforce. Most organizations build on Symantec DLP's inherent fault tolerance features by implementing redundancy at the server level. For detection servers such as Network Prevent for email servers and Network Prevent for web servers that are implemented inline and that analyze live traffic leaving the network, this can mean the implementation of high availability architecture in which multiple detection servers are ready to handle detection requests from a bank of MTAs or web proxies, respectively. For the purposes of this course, high availability, or HA, refers to an architecture in which 1. There is no single point of failure, and 2. The service is always available. For detection servers such as Network Discover and Cloud Storage Discover servers that are not inline, customers may still decide to implement architectural redundancy to support the scanning of target repositories within organizational timelines. For instance, a customer may dedicate 2 Network Discover and Cloud Storage Discover servers to split the scanning of an especially large repository, with one server scanning one half of the directories, while the other server scans the other half. Since a single Network Discover and Cloud Storage Discover server is capable of scanning the entire repository, albeit over a longer period of time, this is not so much an example of HA as it is of architectural redundancy in the service of capacity planning. These next following sections discuss options for server redundancy in greater detail, whether in the context of HA, capacity planning, or disaster recovery, as appropriate for the server type. While reviewing these examples, bear in mind that Symantec DLP is licensed by user count and not by detection server count, which means that customers can install and configure as many detection servers as needed for their particular data loss prevention goals, without incurring additional licensing costs. Most customers have one live instance of the Enforce server in their production environment. Some very large customers, such as those with over 100,000 employees, may have multiple live Enforce instances per global region, or per product area, such as one Enforce for data at rest and another for other product components. However, for most customers, one Enforce instance is sufficient. In addition, as mentioned above, detection servers queue incidents if the Enforce server is unavailable, and then forward the incidents upon reconnection. The scalability of Enforce, along with the built-in fault tolerance of the system, means that HA is not usually a concern for Enforce. On the other hand, Enforce is the center of a Symantec DLP implementation, storing configuration parameters, DLP policies, and highly sensitive incident data, all of which means that a critical consideration for Enforce is disaster recovery. Regularly scheduled backups are the foundation of any disaster recovery plan for Enforce. Symantec supports cold backups of the database, file system files, and server configuration files, as described in more detail in the Symantec Data Loss Prevention System Maintenance Guide. Symantec recommends a minimum backup schedule for Enforce that includes database backups on a weekly basis, backup of file system files and configuration files after changes to Enforce, or detection servers, or after the generation of encrypted keys, and complete backups after installation, before system upgrades, and any time the system changes, for instance when a detection server is added or removed from the system configuration. Network Discover does not run inline in your network traffic infrastructure, but rather it scans repositories for confidential data. Therefore, it cannot be a single point of failure within your network, and from that perspective need not be included in traditional HA planning. However, customers typically give thought to how many Network Discover and Cloud Storage Discover servers they need in order to scan a given amount of data within a specified time. Factors to consider include the observed Network Discover scan rate in the production environment, the number of cores per detection server, the amount of data to scan, the location of target repositories relative to the detection servers, and any organizational deadlines for scans, including any regulatory audit deadlines. It is recommended that detection servers be located as close to the target repositories as possible. For instance, an organization with operational headquarters in Singapore and a large data center in Seattle would want to install enough detection servers in Seattle to scan the local repositories. Such a setup reduces latency during scans, and in this example, requires relatively less bandwidth to send incidents from the Seattle detection servers to the Enforce instance located at the Singapore headquarters. This figure compares two different setups for Network Discover scans. The first, on the left, represents a single Network Discover and Cloud Storage Discover server, scanning a repository containing 5 terabytes of data. The second, at the right, shows 2 detection servers scanning a repository with 10 terabytes of data. Customers who need to scan large amounts of data on a strict deadline can dedicate multiple detection servers to one target repository, thereby reducing the overall scanning time. In the 2-server example, the customer would configure a single Network Discover target to use both detection servers to scan the repository. This is called grid scanning. The 2 scans depicted in this figure should finish in roughly the same amount of time, assuming that network bandwidth, latency, target repository type, and other scan details are equal. From the perspective of architectural redundancy, Symantec DLP Cloud Storage Discover is similar to Network Discover. As mentioned in the previous section, a Network Discover and Cloud Storage Discover server is not a single point of failure within the customer's network. Therefore, the main focus of redundancy planning relates to scanning capacity. As with Network Discover, the factors to consider when planning your Cloud Storage Discover architecture are the scan rate, the amount of data to scan, and any deadlines for scan completion. The main difference is that Cloud Storage Discover scans content residing in cloud-based data repositories, such as Box. This figure shows 3 Network Discover and Cloud Storage Discover servers scanning the content of a corporate Box repository. In this example, the DLP administrator would configure 3 separate Cloud Storage Discover targets that each direct one detection server to scan a specific subset of folders within Box. The more detection servers you have scanning, the quicker the cumulative scan of all Box content will complete. As with Network Discover, you can create additional detection server instances for specific projects without incurring additional licensing costs, and can then uninstall any unnecessary instances after the project has completed. Most customers do not implement high availability for Network Monitor for 2 reasons. 1. Network Monitor analyzes a copy of outbound TCP traffic provided by a TAP or span, and is therefore not inline. And secondly, Network Monitor passively monitors traffic and does not perform blocking, so there is little added risk of data loss if Network Monitor is temporarily unavailable. If, however, an organization considers it important to have redundancy for Network Monitor, there are a couple of options. The first option, shown as example 1 in this figure, is to have one Network Monitor server analyzing live traffic, while a second Network Monitor server is configured identically to the first and is already connected to Enforce. If Network Monitor 1 becomes unavailable, the administrator manually reconfigures the span or TAP to send a copy of outbound traffic to Network Monitor 2. The second option, shown as example 2 in this figure, is to have 2 spans or TAPs, each connected to one of 2 identically configured Network Monitor servers, both of which receive copies of outbound traffic, but only one of which, Network Monitor 1 in this case, being configured to analyze it. If Network Monitor 1 becomes unavailable, the DLP administrator configures Network Monitor 2 to analyze the traffic. As mentioned, most customers do not implement redundancy for Network Monitor, so these configuration scenarios are not common. It is more important to determine how much traffic you expect to have at the primary network egresses, to filter out all traffic such as UDP and voice over IP that Network Monitor cannot analyze, and to size your Network Monitor servers accordingly. For very large amounts of traffic, customers sometimes have 2 or 3 Network Monitor servers, each dedicated to analyzing different protocols. Network Prevent for email runs inline in an organization's email messaging architecture, which means it is important to consider high availability, especially for large enterprises. Customers should determine how much outbound email traffic they need to analyze, how much traffic one Network Prevent for email server can handle in their environment, which may differ from the sample performance statistics discussed earlier based on network specifics, and then decide how many servers they need to handle normal traffic and account for any occasional traffic spikes. Because the Network Prevent for email server is not an MTA and does not store and forward messages, customers retain complete control over their messaging architecture. The example high availability architecture shown in this figure shows Network Prevent for email implemented in forwarding mode with 2 upstream MTAs, 3 detection servers, and 2 downstream MTAs. Here, as in any HA architecture for Network Prevent for email, the detection servers sit behind one or more load balancers. The upstream MTAs forward messages to the virtual IP address of the Network Prevent for email cluster, and the load balancer then distributes the messages across the 3 detection servers for analysis. Like Network Prevent for email, Network Prevent for web is inline in your communications architecture, which makes high availability architecture important for this product as well. Remember that a Network Prevent for web server acts as an ICAP server receiving requests from a supported web proxy, which acts as an ICAP client in this case. This figure shows an example HA architecture in which outbound web traffic is distributed between 2 web proxies, which then forward web transmissions to a cluster of Network Prevent for web servers sitting behind a load balancer. The detection servers deliver a verdict on the transmissions according to DLP policy, and then return this verdict to one of the web proxies via the load balancer. The proxies then forward, block, or remove content from the web transmissions as required. When planning Network Prevent for web architecture, review the list of supported web proxies available in the Symantec Data Loss Prevention System Requirements and Compatibility Guide. Then determine the amount of HTTP or HTTPS or FTP traffic to analyze. Test a Network Prevent for web server to see how much traffic it handles in your network, which may differ from the sample performance statistics discussed earlier, and then decide how many servers are needed to handle normal traffic and then account for any occasional traffic spike. High availability options differ substantially among Symantec's Cloud DLP offerings. For Cloud Service for email and for Cloud Detection Service, all the customer needs to do is contract with Symantec to cover a specific number of users, and the Symantec.Cloud operations team will provision the detection service accordingly. If a customer later needs to cover more users, for instance due to a corporate acquisition, they purchase additional seats for their Cloud Service for email or Cloud Detection Service subscription, and then Symantec will provision the detection services as needed. It is expected that most customers will choose Cloud Service for email, but for those with Cloud Prevent for Microsoft Office 365 Exchange, this figure shown here provides a sample HA architecture. This diagram shows a load balancer distributing email across 2 Cloud Prevent for Microsoft Office 365 Exchange servers running in a customer-managed cloud. Symantec Email Security.Cloud provides the last hop MTA service for the outbound email. Customers with Cloud Prevent for Microsoft Office 365 Exchange install and manage their own detection servers in an approved Infrastructure as a Service or IaaS environment that they have procured. Endpoint servers, which power the Endpoint Prevent and Endpoint Discover products, can accommodate up to 30,000 endpoint agents each, depending on how the administrator configures the server-to-agent connection interval. Remember also that endpoint agents store incidents in a secure local data store if the endpoint server is not available at a given time, and then sends incidents up to the endpoint server when communication becomes available. For smaller implementations, this means that one endpoint server may technically be able to handle all endpoint agents deployed in an organization's environment. Nevertheless, it usually makes sense to plan for redundancy, even in relatively small endpoint DLP implementations. For large implementations, which can include hundreds of thousands of endpoint agents, redundancy planning is a must. An environment with redundant endpoint servers ensures incidents are sent up to the detection server and on to enforce in a timely manner. When creating the endpoint agent installation package, the DLP administrator can specify multiple endpoint servers and/or load balancers for the agent to communicate with. Symantec DLP allocates a total of 2,048 characters for endpoint server and load balancer names. This allotment includes the characters that are used for the endpoint server load balancer names, port numbers, and semicolons to delimit each server. The agent always tries to contact the first detection server or load balancer defined in the agent installation package. If the first detection server or load balancer is not available, the agent tries to reconnect for the specified amount of time before failing over to the second detection server or load balancer configured in the package. For the endpoint server, agents try to reconnect for 60 minutes by default. For load balancers, the connection interval is managed by the load balancer. When an agent reconnects to a new endpoint server, it downloads the policies from that server. This makes it important for the DLP administrator to ensure that redundant endpoint servers receive the same policies so that agent behavior remains consistent. DLP administrators can also define agent groups, defined as groups of agents based on common attributes, such as country, location, or department, and then apply these groups to all redundant endpoint servers to ensure that agents also continue to cover the same endpoint vectors, such as copying to USB, printing, faxing, copying, pasting, and so on. For Endpoint Discover, if a failover occurs during a scan, the initial Endpoint Discover scan is aborted. The agent then downloads the scan configuration and policies from the redundant detection server and starts a new Endpoint Discover scan. For this reason, it is important to assign Endpoint Discover target configurations to all redundant endpoint servers. The example shown in this figure shows 2 endpoint servers in the corporate LAN and 2 in the DMZ. Agents on the corporate LAN, including those connected by VPN, are configured to communicate with one of the LAN endpoint servers first, and to fail over to the second if necessary. Agents connecting from outside the corporate network are directed to the DMZ endpoint servers by a load balancer. All endpoint servers are connected to the enforce server. In summary, review the system requirements and detection server sample performance statistics when planning your DLP architecture. DLP supports VMware ESXi 6.x and Hyper-V virtualization products for most DLP component servers. Virtual appliances are optionally available for the REST API detection server, which is equivalent to a cloud detection service cloud detector, as well as the Network Prevent for email and Network Prevent for web detection servers. Symantec DLP implementations often include a hybrid architecture with components on-premise as well as in the cloud, all usually reporting to a single on-premise enforce server. Consider options for Symantec DLP server redundancy, including high availability for Network Prevent for email and Network Prevent for web, as well as capacity planning for Network Discover and Cloud Storage Discover. To review, the Symantec Data Loss Prevention product suite protects your organization's confidential data. The suite consists of the following products: Network Discover, which scans content repositories for confidential files; Network Protect, which takes protective action on files discovered in content repositories, such as quarantining them, for instance; Endpoint Prevent, which monitors and blocks confidential data from leaving endpoint computers; Endpoint Discover scans endpoint computers to locate and optionally quarantine confidential files; Network Monitor passively monitors a copy of outbound network traffic; Network Prevent for email can monitor and prevent confidential data from leaving over SMTP. Network Prevent for web can monitor and prevent confidential data from leaving over HTTP, HTTPS, and FTP. Cloud Service for email protects cloud-based email. Cloud Storage Discover scans cloud storage accounts for confidential files, which it can optionally quarantine. Cloud Detection Service analyzes data sent by supported third-party cloud services, such as Symantec CloudSock. A full implementation of the Symantec DLP suite consists of a central enforce server, which does policy authoring, server administration, and incident reporting, as well as an Oracle database, detection servers, and endpoint agents. When planning a Symantec DLP implementation, review system requirements and detection server sample performance statistics carefully. It is also important to consider the options for server redundancy, including high availability for Network Prevent for email and Network Prevent for web, as well as capacity planning for Network Discover and Cloud Storage Discover. Many implementations now include a hybrid architecture with components both on-premise as well as in the cloud, all usually reporting to a single on-premise enforce server. For additional information on each product in the suite, as well as system requirements and compatibility details, please see the following documentation: the Symantec Data Loss Prevention Administration Guide, the System Requirements and Compatibility Guide, the MTA Integration Guide for Network Prevent for email, the Cloud Service for Email Implementation Guide, and the Cloud Detection Service Getting Started Guide. Thank you for joining us. This concludes the Symantec Data Loss Prevention Overview module of the Symantec Data Loss Prevention 15.5 Administration course.